Now recording. All conversations will be appropriate. Here we go. So you stored credit card numbers in a file, and they were coded by this little cute 2x2 matrix. And then you got this encoded credit card number. Does everybody understand what the situation is? Yes? Okay, so really we have some retired math teacher who's like, I miss doing math. Let me like encode my stuff in the like most awkward way possible, is pretty much where this is. Now this problem does come from an actual application because matrices are used to encode things, but they use much bigger matrices than this and many more layers of encoding, and a computer does it, right? But fundamentally, this is the basic process that's being used. So if that is the coding matrix, I need a different matrix to decode. What matrix do you think I probably need? The inverse matrix, right? Because we would be reversing the process. So first of all, I'm going to need the inverse of this matrix. Now, normally, I would make you find an inverse of a 2x2 by hand, right? That is a level on which I would expect you to be able to work. But for the purpose of this problem, what I really care about is that you know it's the inverse that you need. Does that make sense? And the actual multiplication we're going to do is going to be of a size that I wouldn't ask you to do by hand. So we're going to let the calculator do the whole thing. You're welcome. Okay? So now I do need to think about this. This is a 2x2 matrix. So the matrix for the credit card number has to start with which dimension? The matrix for the credit card has to start with which dimension, Amelia? A 2. Okay, so this next matrix needs to be a 2 by something. Okay, in order to figure out what the something is, how many digits are there in the credit card number? 16. Okay, so if this is going to be 2 by something and it's going to fit a 16-digit number, it's going to be a 2 by 8. Does everybody see how we figured that out? Yes, we're okay? All right. So this matrix is going to be a 2 by 8 matrix. So I want the first 8 numbers to be in the first row. And the next 8 numbers to be in the second row. And now you can see why I would not ask you to do that by hand, right? That would be kind of awful. Why won't this erase? There we go. So you're going to grab your calculator, and you're going to see that you can actually get the inverse of the matrix simply by putting in a 2x2 matrix and using the x to the -1 button outside the matrix, okay? Telling it to take the inverse. And then you're going to put in a 2 by 8 matrix, which you might not be able to do with the alpha zoom. You might have to go up and use the actual matrix menu. I can't remember if you can do it with alpha zoom or not. But I try it along with you. Let's see if I can get my calculator. Only goes up to 6. So you're going to have to do it by like calling matrix A a 2 by 8 and putting it into A and pulling it that way. Because there you can make the matrix pretty much as big as you would ever want to make a matrix, okay? Not infinitely, but as big as you would want to make the matrix.
You can make it
up to 40 by 40. Sounds lovely. All right, do you need me to walk you through it, or are you okay with doing the steps on your own? I just need to know. Do you want me to do it, or you want to just do it, and you'll tell me the answer? Where are we at? I need a response. Mrs. Leonard, please do it with me, or Mrs. Leonard, I can do it on my own. Do it with you. Thank you, Evan, for giving me a response. Okay, so I'm going to demonstrate both of the methods. I'm going to use the shortcut for the first one, and then I'll use the long cut, the other one. So I'm going to get the other one in there. I'm going to do second matrix. So second x to the -1 takes me into the matrix menu. I'm going to go over to edit, because I want to actually create a matrix. You can choose number 1 and type over it. I'm just going to go down to number 3, matrix C, because it's empty. And I'm going to tell it I need a 2 by 8 And now it will give me an appropriately sized matrix. I'm going to type my numbers in there. When you're in this menu, you can use Enter to move around, whereas when you're in the other one, you have to use the arrow keys. Oh, the computer calculator is so terrible. It like doesn't know when I push a button twice. So I have to go super slowly. Oops. Oh, that took forever. All right, once you get your matrix, you can quit out of there. I'm going to clear what's on my screen. So the first matrix, because remember multiplication is not commutative, so I have to enter them in the correct order or I will not get the correct answer. Okay, in fact, in this case, it'll just tell me an error and it won't even multiply them. So I'm going to use the shortcut to get the first matrix in there. Remember alpha zoom. And then mine happens to be ready for a 2 by 2. I could adjust the size. So I'm going to enter that one using the arrow keys to navigate around, because that's just how it works for this particular shortcut. Then I'm going to come outside the matrix, and I'm going to use the x to the -1 button to tell it I want it to find the multiplicative inverse of that matrix, instead of us doing it by hand like we did the other day on a previous problem. Then I want to multiply. Now I need to go find that matrix. So if I go to second, x to the -1, that takes me into the matrix menu. And I put this in C. So I just need to choose matrix C. And that now represents that entire 2 by 8 matrix. When I hit enter, it gives me my matrix. Is everybody okay? Yes or no? If you have an older operating system, it won't display as nicely on your screen. The matrix will probably run off the screen and you'll have to use the arrow keys to navigate around, but it is all there. You just have to look for it. So it gives a matrix of this. So for credit card numbers, if you've ever seen a credit card, they're chunked in 4-digit sections. So the credit card number would have been 2455 1187 3221 5532. So that was the original unencoded credit card. Are we okay? Yes, we're good? All right, so now we're going to go back up. We're going to do problem number 3. So here's what I need to say about problem number 3. So I'm a math teacher. I would not call myself a mathematician. I don't make up new math. I just tell people how to do math that people already know about. Does that make sense? Okay, but there are people who are actual mathematicians. Their job is to discover new mathematical properties, to prove that things work or do not work always, to consider like really fancy mathematics that relates to different aspects of science. Like that's what mathematicians do, okay? So sometimes mathematicians discover things that they find very interesting that the rest of us are like, okay, I don't think I'd ever use that. And problem number 3 would be an example of one of those things. So someone recognized a pattern. They discovered that you could do something in a certain way. We're going to look at it because the book thinks this is important. There's one homework problem related to it, okay? But I would venture to guess you will never use this again in your life after you practice that one problem, okay? So I'm just telling you, I don't think that this is particularly practical, but it's true and interesting that it works. So let's take a look. It says, the area of a triangle with vertices x sub 1, y sub 1, et cetera, so like vertices on a coordinate plane. You can calculate the area of that triangle with the following formula. 1/2 times the determinant of A, where A is the coordinates, with an extra column of ones so that it can be a square matrix. Everybody okay? Right? Because we can't do things like finding the inverses of matrices that aren't square. So they needed it to be square. So we're just going to accept that this has been proven to be true. So then going beyond the fact that this is a really specific formula that we are absolutely not going to be asked to memorize or ever be able to recall on our own later, the word problem is really laughably contrived. So let's take a look. It says, as part of a remodeling project, you want to paint a triangular area on a cement floor. Already we're okay, sure. That is marked along the wall with decorative stones every meter. How convenient. There is a coordinate plane built into our room. Okay, using the stones as a reference, you determine the coordinates of the vertices of the area you want to paint are these 3 points. What is the area of the triangle? All right, so let's just do it to show that we can. So basically, notice this matrix, it just takes the coordinates and lists them above each other and then adds a column of ones. So we'll do that too. So now we have a 3 by 3 square matrix. Everybody okay? Yes? All right. Next, it says I'm not just supposed to make this matrix, I'm actually supposed to find the determinant of this matrix. And you all know that I don't ask you to do that by hand if it's bigger than a 2 by 2, so this is going to be a calculator thing. Once we have found the determinant, we're then supposed to take 1/2 of that. So you can type that straight into your calculator. You can do 1/2 using the alpha y equals, pull the 1/2 in there, right? Pull the fraction in there, and then times. And then you're going to go into your matrix menu. So you're going to do second x to the negative first to get into the matrix menu. Just use determinant off the math menu in there. It's the first option. Then you can either do the matrix on your screen or you can store it and pull it in, but you need to make that 3 by 3 matrix. When you get all done, you'll hit enter and poof, you'll have the area of this triangle that you want to paint on your cement floor. Evan, how big is it?
Actually,
Question?
I'll tell you that.
Okay.
Yes, but doesn't it have to be absolute value instead of parentheses?
Only if the determinant's negative,
Okay.
but yes. So there is a feature in your calculator. So if I go back to the calculator, I think alpha window. Yep. With alpha window, there's the absolute value right there. You can also find it under math. If you go math, number, there's the absolute value. Michael, did you find it somewhere else as well?
Yeah, if you go into second and then 0, it brings you to the catalog, which is literally the first thing there.
Oh, second 0 will take you into the catalog. So there are 3 different ways to put that thing into an absolute value rather than parentheses. Sorry, I've done this problem a couple hundred times, and I know that it comes out positive, so it technically should be an absolute value. All right, what do we get?
I got 119.
How much?
119.
119? 31 over 2. 31 over 2. So 31 halves, right, or 15 and a half. What is this? There isn't even a good unit that we can use. It's squared. Oh, squared, right? They were every meter? Okay, so at least we get a legit unit. Meters squared. Very awkward problem. Are we okay? Yes, we're okay? All right.